Hello, and welcome back to Learning with Lee. In today's episode, we are going to take a look at namespaces and splitting your program into multiple files. We've already encountered namespaces a little bit in terms of using namespace standard, which, as a reminder for why we included that here, it's so as that we don't have to do what are known as qualified namespaces or qualified names in front of each of these locations here, so it makes our code much cleaner to just use this at the beginning. Now, there are some ways in which I could theoretically even make this a bit simpler, because right now this is saying that I want access to everything that is in standard that is included within these two here. And there's a whole bunch of things in string and standard that we don't really care about. So I could instead do is go with this, and this happens to be going something like that. Says I'm using string. I could do this to say I'm using endl, and just use it for all of things I particularly care about along the line there. And that also using cout. And then we shouldn't have any more problems with that, because those are the only three things we're using. And while that's useful to say that we're only needing these things and it helps your compilation be a bit quicker, because right now, in case I had gone back to how I had it previously of just using namespace standard, right now your compiler is going to have to check through all of standard and as well as through your file to see what exactly from there you're using. So it can be a bit quicker in case you happen to declare explicitly what you're going to use. As well as there's also the risk that I might create something like a SquareRoot function here that happens to conflict with something within standard, such as standard might have a SquareRoot function if I were to bring in some of its math libraries. It probably happens to be named differently than mine is, but for that purposes, we could guess that there might be that sort of thing there. Or in case I was bringing in somebody else's custom math libraries, then I might end up having some naming conflict there. And that could lead to some questions as to which SquareRoot this is actually supposed to use. Is it supposed to use this one here? Is it supposed to use whatever one they have in that namespace there? So if you run into one of these problems where something you've created's name conflicts with something that's in another library, or two things that are in different libraries that you're using have conflicting names, rather than doing something such as using namespace standard, write something along the lines of standard : and then whatever you end up needing that's conflicting. So in this case here, in case my SquareRoot function conflicted, I could use standard : SquareRoot if I wanted to use that one. Or once I create a namespace for this, I can end up using that namespace as a prefix. The next thing that you use it for is to sort of split up like sections of your program, and this is something that we use multiple files for as well. So I'm going to get started by right-clicking on source, going to new, and then down in here you'll see these different options, and the major ones are header file and source file. And we're going to start off with a header file, and we're just going to name this one SquareRoot.hpp. And the reason why I go with .hpp as opposed to .h, and both of these are valid, you'll see up here that if I don't have anything it gives me this error. But if I go with .h, that signifies that's C header. If I go with .hpp, that's a C++ header. In general, neither one of those is really going to cause a problem for you here, but we're just going to go with .hpp. Do this, and you can see in here, it already has a few things for us. It has some comments, and over here, it has these preprocessor directives. And we've already gone a little bit into preprocessor directives in the introduction to what are the different parts of a program, and we already showed them some with include statements up here. And what these do is these happen to tell the compiler to do a couple things. The first is that in the event that this token SquareRoot_HPP_ has not been declared yet, then you want to execute everything between here and this endif. The first thing that you do within there is you define and create that token so as that in the event that this header file gets loaded multiple times during compilation, everything within that header file is defined only once. And this helps prevent errors within your compiler, as well as also makes it go quicker and just makes everything a lot cleaner, because then effectively there's only one instance of this header file being used by your compiler, even though this header file might itself be included in multiple files such as intro. In a few seconds we're going to be creating a SquareRoot.cpp file. So what you use your header file for is you just copy your declarations from, say, here into here. And the reason why we use multiple files for this rather than just having this all in one file is that A, it's a lot easier to read as a developer. It's a lot easier for somebody who's new to your program to come on in, see how things are laid out, get a better understanding for it. B, it makes it much easier to load this file into an IDE, as well as then if you make any changes to that file and you save it, then it ends up making that saving process much larger because it's much easier to have multiple 1 kilobyte files, some that might even reach, 60 or 70 kilobytes in size, but it's a matter of you don't want it to be half a gigabyte as a single file, because then when you go to save that file, that's going to take a really long time, even if your entire project might be multiple gigs. And when you start dealing with really large professional industrial scale applications, you're going to start seeing things that reach that size in terms of how much code there actually is. So now that we've copied those over, we have these here, we can create a namespace for these. And the way you do that is you just go namespace and whatever name you want it to be, then you create a scope, because a namespace really is just a named scope. It's just saying that within whatever scope, and you can reference it by name, so within the scope standard, we have things such as cout and endl, and you have the ability to then access that scope by using that namespace, or by going with the std::. So in here, though, we're saying that namespace, and we'll just call this SquareRoot up here. We have these two functions. Then over here, we can create a new file for our source, which happens to be, in general, our definitions. So within that, we're just going to go SquareRoot.cpp, because .c is a C file, .cpp, C++ file. So we're going to create this here. The first thing we need to do is we need to create what are known as these include statements, and we'd already examined them a little bit earlier in terms of using them to include the string library and the IOStream library, so as we could do this as well as also this. But what we need to do now is we need to include this header file, because let's say that I had a larger program that might have 100 header files in it, and that's not unreasonable to consider. So in that case there, what you would end up having to do is, if you didn't have to do those includes, is your compiler would have to assume that whatever you're using here is dependent on all the header files in your project, and it would increase significantly the amount of work your compiler would need to do, and it would make compilation a massive, massive time sink, far more than it already is. So what you do is you go #include as before, and here's where it changes. Previously, we had used the less than and greater than signs in order to signify that we were declaring an external library, in particular a system library. In this case here, though, we want to include something that's custom, and for that you use these quotation marks. And what you put within there is some path. In this case here, because they're all in the same location, all in the same folder, it just happens to be the name of the header file that we're looking for, so SquareRoot.hpp. However, if I had SquareRoot.hpp within a separate folder, I could call it something such as, in case it was in the headers folder, I could do headers and then /SquareRoot.hpp, or technically, since this is Windows, we would do headers /SquareRoot.hpp. But for now, this happens to be good enough to understand what we need to do there, so that it specifies to the compiler that we care about what's in here. Then we can just take our previous SquareRoot definitions that we had in here, cut them out of there, move them over to here. Now you're going to notice a problem here, and that's that, well, you might not notice a problem yet until I build it. So let's just build it so that we can see what the error here is. And that's that, first off, within here it's going to complain about the fact that down here we don't have this for using namespace standard. But before that, we have the problem of, A, this one here isn't aware of this one down here. It's only aware of this one here, which is why it's giving us this error. And that's because these are both within the namespace SquareRoot. So for this, what you can do is you go up here, do that, and then down here, do that to specify that these are the two of those, as well as then you can also do this. Now you might find that SquareRoot, let's say that I had a whole bunch of different things defined within here, that's a bit long. So what you can do is you can do what's known as an alias. So what I can do then is I can go namespace, and we'll just call it SR equals square root. So that now, as opposed to this, I just have to do SR double colon, and this allows it to be much shorter and easier to use. In this case here, it's probably just cleaner to use square root there, but here we can also then, because we also now have to include IOStream, since we are outputting things, we can just put that there, head on down here, go standard colon, and then if I build this, it's only going to give us errors over in this file because of the fact that we have not yet included this header file. So for that, once again, same thing as what we did over here. We copy this line here, put it in here, since this file, like this file, needs access to these declarations. Then we can save it, we can build it, and yes, because these happen to not be within there, I actually have to use the namespace SquareRoot, and it tosses that there for us, and we can just put that in each of those. And that'll fix the bugs we were having previously. We can build it, we can run it, and as you can see, it still works, even though it's now split across multiple files. For Linux, Macintosh, or Unix compilation, we would need to create what's known as a makefile in order to do this. However, thankfully for us, the multiple files and compiling that all together gets taken care of for us by the IDE as well as by this project when we're dealing with Visual C++. So we don't have to worry about specifying that this file here depends on this one in any other way other than this include statement right here. And as I had mentioned earlier, we have these definitions here of this here. And the whole reason, and the best example I can give here, is the fact that we're using it in this file as well as in this file. So whenever we encounter this include, the compiler is going to end up loading in whatever is within here for the first time. Then the second time we encounter it, it's going to try to load this again, encounter this thing here, not end up loading any of this because it already exists, and it'll just use the pre-existing definition of this namespace and declaration of these two functions. This brings me to one of the most important things that we use namespaces for, and that is what's known as creating interfaces. And what an interface is designed to do is it's designed to ensure that, let's put it this way, for example here we have these two square root functions, and this square root function really should never be used by anything other than this square root function. Because we can't guarantee that somebody else is going to set up things like the delta and the threshold correctly. And really, it's more complicated than any other consumer needs to understand other than this one. And frankly, we don't want intro to have to care how that square root function is implemented. We don't want it to care whether or not that function happens to be a for loop, whether it happens to be some mathematical operation, or whether it happens to be, in this case here, recursive. So what we can do here, instead, is create a separate namespace as an interface. So within here, we can just go namespace, and for this, the general way in which I've most commonly seen it done is you just add an I as a prefix to your namespace, and any place you end up working will have their own specific design patterns and the like that they'll expect you to follow for how they specify whether you name these square root implementation or this I square root or anything else like that. So then in here, we could either directly just move this thing up here, get rid of this guy down here, and change this one over so that now this is in I square root, but we'd have to copy that over. However, alternatively, what we can do, and this happens to be relatively easy, is we can just leave this guy down here, put another one up there, that in turn, what it will do, and we can just define it up within this file itself. In general, it's not considered good practice to define things within header files. However, for very lightweight, small things like this, it makes pretty good sense to define it within the header file rather than splitting it off. Because all that this is going to be doing is it's just going to be calling square root function and passing in value and threshold. So what it does is it does what's known as abstracting this down here, so as it's hidden behind this interface here. So there still are two more problems I need to take care of real quick. The first is that I need to return this here. The second problem is that because of the fact that I've declared this namespace after this one, it's going to have an issue finding that. Now there's a couple ways I can do this. The first way I can do it is I can create another header file. And for this one here, I'm just going to go with SR And this just will be for our use of the interface. So what I can do then is I can just copy this guy over into here, have this guy end up using SquareRoot.hpp, so as that we really end up hiding this from intro over here. And then over here what we do is we use SquareRoot, and we can just then rename this to ISR on each of those. Because the problem that we had there was that this namespace in this file, when we had it in our header file over here, was declared before this one was declared, so it wasn't aware of that namespace. So now, this one here will get the information out of this header file, be like, okay, here's this other namespace, and then it will be able to be aware of SquareRoot within there. So then I can build this, I can run it, and once again, everything works, even though it's now split up over multiple header files, over multiple files. And we've effectively hidden this entire implementation of these two files behind this interface here. So what I would like you to do is take a look at splitting up the rest of the stuff we've worked on, the stuff I've had you work on over the past couple episodes on your own, into their own logical, consistent header files, C++ files, etc., in case you want to combine things such as the lowest common denominator, least common multiple, and square root functions all behind, say, your own custom math interface. That would actually make a lot more sense, rather than defining a custom interface for each of them. So, thank you very much for watching. I hope you have a wonderful day.